All right, hello. And today we are going to start our geometry unit. The very first section we're going to work on is just the fundamentals of geometry. However, this is a somewhat long section. This why I call this part 1. And then after we go through this, we will then do another video for part 2 of this section. The first thing we're going to do is look at labeling different types of parts of our geometry. We're looking at lines, half lines, points, angles, and so forth. And what we want to be able to do is just to be able to identify them. So if you want to label these in your notes, this can let you know when you're looking back what type of figure this is. This one I think we can probably all figure out from the directions when we look up here that is a point. This is, it looks like a line, but only goes infinite in one direction, which means technically that would be like your end point. That is what we call a ray. And then if we have two rays that form a common endpoint, we call that an angle. This, we have a line going in infinitely in both directions. That is what we simply call a line. Think about graphing. When you used to graph linear equations, you would have a line, which meant it went infinitely in both directions. Now this, I always think of it as kind of like taking a chunk of a line or a segment of a line. And so we call this a line segment. And here we have two endpoints. This does not travel infinitely in two directions. This last figure, it looks very similar to a ray, except that it has an open circle, which means we're not including that endpoint. This is what we call a half line. It goes infinitely in one direction, but we're not counting the endpoint. And I kind of gave this away, but two rays with a common endpoint form an angle. And you can see over here we have your image of an angle. And angles are always measured in terms of degrees. And a lot of time we use that symbol, that little circle. So if I said something was 40 degrees, we would use that little symbol, or you could say 40 degrees. You could actually spell that out. Now we also have different types of angles, and it all depends on their characteristic or properties. Whenever you see the square, that indicates a right angle because this equals 90 degrees. So whenever we see a square, that means we have a 90-degree angle. The two rays are perpendicular to each other. This shows us that we would actually be looking at an angle that is greater than 90 because notice it leans further. That is what we call obtuse. I'll put it's greater than 90 degrees. This angle is actually smaller than a 90-degree angle, so we will call that acute, and those would be less than 90. The line right here, it's a straight line. We call that a straight angle. And this equals 180 degrees. So it's basically like if you took this right angle and laid it out flat, you end up with a straight angle, which is 180 degrees. Now let's talk about complements, right? Complementary angles and supplementary angles. A complementary angle would be two angles that add up to 90 degrees. and two supplementary angles add up to 180 degrees. Now, the way I always remembered this was C comes before S in the alphabet, and 90 comes before 180 in our number line. That's just how I remembered it. So just one thing to see if that helps. Number one, we want to find the complement of the angle with degrees of 35. So we know the two angles are complementary. That means I'm going to take 90, take away 35 to get the complement, and that would be 55 degrees. And here we want to find the supplement of an angle with a degree of 110. In that case, we know that two supplementary angles add up to 180. And so I want to subtract, and I get 70 degrees. All right. Now let's talk about the dimensions of an object. When we are looking at this, it can be thought, I'm going to write this out, but one of the ways it can be thought of as the number of independent directions you could move if you were on the object. Now let me explain. So I'm going to give you some examples to kind of explain what that means. A point. A point has 0 dimension. Since you cannot move anywhere. So think about it, right? You have a point. That's it. You are on that point. You're not moving anywhere. You're not moving in any direction, so you would have 0 dimension. Now let's go up another one. How about a line? Well, in that case, this would be 1-dimensional. And that's because with the line, you can move forward or backward in one direction. Right, so think about what we looked at before when we were looking at a line. We had this line. Okay, you can move forward or backward, but it's just in one direction only. That's it. Now let's go up another one. A plane. If you kind of think of the plane, we used to talk about the coordinates, plane, but just an example, we could call that a plane. This would be 2-dimensional. All right, and the reason why, because, and let me just show you on here. So here's my little plane that I drew here. You could move north and south, and you can move east and west. Think about like a floor. You can move north, south, east, west, but in the plane, that's basically what we're talking about in terms of movements. It's 2-dimensional. So I can move north, south, east, west. The last one I'll use is 3-dimensional. And what will make something 3-dimensional is now I can move north, south, east, west, up and down. So we added that third dimensional movement to it. So I can move north, south, east, west, and then up and down. That adds that third dimensional. Now, this ends the part 1 of this section. And so your next video will then cover part 2, which is area and volume.